morning students, myself Dr. T. Sudarshan Ramaperumal. Today we are going to see about the introduction of data link layers. So the TCP/IP protocol does not define any protocols in the data link layers or physical layers. These two layers are the characteristics of network that when connected make up of the internet. These networks, wired or wireless, provide services to the upper three layers of TCP/IP. Communications at the data link layers is node to node. A data unit from one point in the internet needs to pass through many networks to reach another point. These LANs and WANs are connected by the router. It is customary to refer to the two end hosts and the routers as nodes and the networks in between the links. The simple diagram how the data will be transmitted from the source to destination using only the physical and data link layers. For intermediate, we have only used the LAN switches and routers. The data link layer is located between the physical and the network layers. The data link layers provide services to the network layers. It receives services from the physical layers. When a packet is traveling in the internet, the data link layer of a node is responsible for delivering a datagram to the next node in the path. For this purpose, the data link layer of the sending node needs to encapsulate the datagram received from the network in the frame, and the data link layer of the receiving node needs to decapsulate the datagram of the frame. One may ask why we need encapsulation and decapsulation at each intermediate node. The reason is that each link may be using different protocol with different frame format. When if one link and the next are using the same protocol, encapsulation and decapsulation are needed because the link layer addresses are normally different. Here the source will send the datagram. In the datagram we add the sequence numbers, and the intermediate node only receive the data and check the destination as whether our data or not. If the data is not corresponding to ours, it will be transmitted over the link, and the destination will receive the data and check the destination address. If the destination address is matched, it decapsulates the data. Framing. Definitely the first service provided by the data link layer is framing. The data link layers at each node needs to encapsulate the datagram in the frame before sending it to the next node. The node also needs to decapsulate the datagram from the frame received on the logical channel. The frame may have both headers and trailers. Different data link layers have different formats and for framing. Flow control. Another one important work for the data link layer is flow control. The sending data link layer at the end of the link is a procedure of frames. The receiving data link layers at the other end of the link is consumer. If the rate of produced frames is higher than the rate of consumed frames, frames at the receiving end needs to be buffered while waiting to consume. Definitely we cannot have an unlimited buffer size at the receiving side. We have two choices. The first choice is to let receiving data link layer drop the frames it in buffer is full. The second choice is to let receiving the data link layer send feedback to the sending data link layers to ask to stop or slow down. Different data link layer protocols, different strategy for flow control. Error control. At the sending node, a frame in a data link layer needs to be changed to bits, transformed to electromagnetic signals and transmit through a transmission media. At the receiving node, electromagnetic signals are received, transformed to bits and put together to create frame. Since electromagnetic signals are sustainable to error, a frame is sustainable to error. Error needs first to detected. After detecting, it needs to be either corrupted at the receiver node or discarded at the retransmitted by the sending node. Since error detection and correction is an issue in every layer. Two categories of link. Although two nodes are physically connected by a transmission medium such as cable or air, we need to remember that the data link layers controls how the medium is used. We can have data link layers that use the whole capacity of the medium. We can also have a data link layer that use only part of the capacity of the link. In other words, we can have a point-to-point link or a broadcast link. In a point-to-point link, the link is dedicated to the two devices. In a broadcast link, the link is shared between several pair of devices. So next, the data link layer is divided into two sublayers. To better understand the functionality of the services provided by the data link layers, we can divide the data link layers into two sublayers. First one is DLC, data link control, and media access control. The data link control sublayer deals with all issues common to both point-to-point and broadcast link. The how the addressing will be used in the data link layers. So types of address, three types of address: unicast, multicast and broadcast. In unicast, each host or each interface of the router is assigned a unicast address. Unicast means one-to-one communication, and multicast address, some link layers protocol